A direct proportion is a direct proportion where P is directly proportional to Q is a relationship in which P is equal to some number K times Q. Whatever P is, it's equal to K times whatever Q is, where K is an unchanging number. It's a constant number, single constant number. P and Q can vary, but K stays the same. K is called the proportionality constant. We also have inverse proportion. P is inversely proportional to Q if P is equal to K over Q for some, again, constant number K. Whatever P is, it's equal to K divided by whatever Q is. So, for example, in this case, if Q gets bigger, P is going to have to get smaller because you're dividing K by a bigger number. Here, if Q gets bigger, since you're multiplying Q by this proportionality constant K, P is going to get bigger. Okay, so we have the first problem says that Y is directly proportional to X. And we ask how you would write the equation and so forth. Well, instead of P directly proportional to Q, we have Y directly proportional to X. So instead of P equals KQ, we're going to have Y equals KX. Everybody got that? Then you're given a couple of values. You're given that Y is 20 when X is 2. So what do we do with that? Well, we substitute 20 for Y, we substitute 2 for X, and we get an equation that we can use to solve for that single constant number K, our proportionality constant. Well, this is very easily solved for K. Divide both sides by 2, we get K equals 10. Okay, the next step is to write out the specific equation. So for this situation, where Y is directly proportional to X, and Y is 20 when X is 2, our specific equation then has to be Y equals 10X, because in this specific situation, K is 10. Now, using this, if X happens to equal 9, then what is your value of Y? Well, our relationship is that Y is 10 times X. So if X is 9, Y has to equal 10 times 9. So Y is 10 times 9, which is 90. Now, X went from 2 to 9. X increased. Actually increased by a factor of 4.5, because 9 is 4.5 times as big as 2. Y went from 20 to 90. Okay, well, 90 is 4.5 times 20. So it seems that, at least in this case, if X increased by a factor of 4.5, Y increased by a factor of 20. Okay, well, next question is, what is going to happen to Y if X doubles? Now, from what I've just said, you're probably going to have a pretty good opinion about what's going to happen. Well, to justify your opinion, which is probably that if you double X, Y is also going to have to double. How do you get Y? To get Y, you multiply X by 10. Okay, if you multiply by a bigger number by 10, you're going to get a bigger result. So if X gets bigger, you're going to be multiplying a bigger number by 10, you're going to get a bigger result. And in fact, if you multiply a number twice as big by 10, you probably are going to expect to get twice the result. Now, we can prove, in fact, that this does happen, that if you double X, Y is going to have to double. Okay, to prove that, we just let X2 equal 2 times X1. X1 could be any number, but now X2 is going to have to be twice that big. So we're going to regard that, we're going to assume then that X is doubling. It's doubling from the value X1 to the value X2. Now we're going to let Y1 equal 10 times X1. So that's what our proportionality equation would give us for X1. Y1 will correspond to X1. And Y2 is going to be 10X2. So Y2 is the Y value you would get if you plug X2 into the equation for X. Well, in that case, excuse me, Y2 over Y1 is going to equal 10X2 over 10X1, because that's, of course, what Y2 and Y1 are. And 10x2 over 10x1 is just x2 over x1, because the 10 is divided by the 10, and you're just left with x2 over x1. But x2 is 2 times x1, so that your y2 over y1, which is equal to x2 over x1, is now equal to 2x1 over x1. And now x1 is divided by x1, leaving you just 2. This says then that y2 over y1 is 2, and it's not much of a stretch to see then that y2 has to be twice as big as y1. It's the only way y1 over y2 could equal 2. So that doubling x doubles y. Now I could just say, to complete the argument, y2 over y1 equals 2, which we've established, implies that y2 does equal 2 times y1, so that y2 is the double of y1. And since that's what we got, starting with the assumption that x2 equals 2x1, we've concluded that when x doubles, y doubles.